Hello everyone. So today's video is problem you must try, question number 29, and this question is, I can say, from calculus, sent to me by one of my student. I don't know the actual source of this question, but it is a very beautiful question and a lot of mathematics we are going to explore while we solve this question. So if you solve this question correctly, if you want to give a try, that will be more appreciated. And the answer would be log 3 the whole square, as you can see here. The question reads like this: n goes from 0 to infinity. When nothing is given there, it means infinity. And m goes from 0 to infinity. And the numerator of this expression is going to be 1 by 4 to the power m plus n. And in denominator, I have 2n plus 1 and m plus n plus 1 is given. So how do we solve it? Of course, if you think naturally, by just plugging the values of m and n, it will be very lengthy question or lengthy solution, I must say. So how we do it, let's see. But before jump to the solution, I request you to first give an attempt for 5 or 10 minutes. So now the solution. First of all, suppose I ask you one thing, that 1 by, let's say I'm writing here, n plus 1. My question is, can I write this 1 by n plus 1 as the result of a definite integral? Yes, we can write. We can write it as 0 to 1 x to the power n plus 1. Because 1 is a number, it is very useful. And here when you integrate, not n plus 1, by the way, it's n. So when we write it here, dx, of course, when we integrate it, we get 1 by n plus, means x to the power n plus 1 by n plus 1. And when we substitute the pounds 0 to 1, we get exactly 1 by n plus 1. So can we write this the expression for the summation which is given there in the form of integration, and then we switch the summation sign or swap the summation sign with the integration sign? So here is the clue. The clue is 1 by 4 to the power m plus n, and here m plus n 1. So what I'm going to do, I'm taking this m plus n plus 1 as n plus 1, and I'm writing this 1 by m plus n plus 1 as the result of some integral here. So my expression, let's call this thing as the summation. And the summation what we have is summation n goes from 0 to infinity. I'm not writing infinity. And m goes from 0 to infinity, and here 1 by 4 m plus n, and denominator 2n plus 1. And this guy, m plus n plus 1, I'm writing as the integral of 0 to 1 x to the power m plus n dx. Now this whole idea is to swap the integration sign with the summation sign. And you can ask one valid question, that why you took this constant as our integral, like to write the result as the integral of this. Why not we have taken this to n plus 1? The valid answer is this one, because I can see here is also m plus n and here is also m plus n. I can combine them together to give some fruitful result. So again, what I'm going to do is I'm just swapping this integration sign with the summation sign. It means swapping in the sense that means we are taking the integration sign out and doing the summation sign in. So this is 0 to 1, and here n goes from 0, then m goes from 0 to infinity, and these two, this guy and this guy, I'm taking together. So when I take it together, I can write it as what? This 1 by 2n plus 1 as it is, and this will I'm writing x by 4 to the power m plus n, and this is summation already here, and dx. The idea is that when you add them by using the summation sign, and whatever result come in terms of x, I will again integrate it. Earlier it was you are integrating this first, and whatever result come in terms of m and n, you are applying the summation sign over. So this is actually a very useful technique in calculus, that we can actually swap the summation and integration sign with each other. Now this I can club. You can see this is m plus n here. So I'm just splitting into two parts. How am I splitting? N goes 0, then m goes from 0 to infinity, 1 by 2n plus 1, and here I'm writing x by 4 to the power m and x by 4 to the power n. Now it's very useful that you can see the summation, one summation runs for n, one summation runs for m. So I can take the terms containing n together with the summation which is running for n, and so for the m. So here I'm writing the summation n running from 0 to infinity, and this is n, so I'm taking this 1 by 2n plus 1 with x by 4 to the power n. This is one summation I have. Second summation, I'll take m goes from 0 to infinity, or not right, no problem, x by 4 to the power m, and this summation is for m, and whatever result comes again, I'm going to integrate it. Now this is the entire summation I had to find, but now inside the integration sign I got two distinct summations. So I'm just calling this as S1 and this as S2, and we can take it separately to find out what the result will come in terms of x, and then whatever result comes, again we integrate it for 0 to 1. So first I'm taking S2, and S2 is going to be a little bit easier. M goes from 0 to infinity, and this is x by 4 to the power m. Now you notice that I have taken the integration here. I introduced this x, but while introducing this x, we have to be careful. That means we have to observe this thing, that we have taken 0 to 1. It means the x lies from 0 to 1. So in this way, this x by 4 will be always lesser than 1, and this will construct an infinite GP, because you can see that this is 1, then this is x by 4, then x by 4 whole squared, then up to infinity. Is an infinite GP, so I can directly write the sum of this infinite GP of the S2. So that is going to be 1 by 1 minus x by 4, which can be written in the simpler way as 4 by 4 minus x. Now again we take the S1, and S1 a little bit challenging and also interesting. It's a fun to do it, so let's do it. S1 n goes from 0 to infinity, and this is nothing but 1 by 2n plus 1, and here x by 4 to the power n. Now, so let me write it a little bit clearly. So I'm writing here S1 is summation n goes from 0 to infinity, and x by 4 to the power n divided by 2n plus 1. Now how do we deal with this situation? That's an interesting kind of thing. When I was discussing this problem with my student, I also struggled for a few minutes. Then we together came up with a very wonderful idea to deal with. Now notice, if you try to expand it, the first term will become 1. The second term will become x by 4 into, and that is going to be 1. So 1, 2 plus 1, 3. So that will be 3, and so on. So it's a very difficult to get the idea from here. But notice that if I suppose x by 4 is a place value of something, we can think a little bit wiser, and we can wisely rather, and we can think a little bit in correct direction. So for that, I'm thinking on this situation that I have summation n goes from 0 to infinity, and let's say x by 4 is not x by 4. I'm taking t to the power n and divided by 2n plus 1. Now if you want to write, and now suppose I get this expression, I mean the expansion, and at the place of t I can substitute x by 4, and of course we can get the answer. Okay, so for that, let's try to expand and see what will happen, the consequence, and then we come out for the solution. So now this is 1, and this is going to be t n is equal to 1, so that will be t by 3. Then t to the power 2 by 5. Then t to the power 3 by 7, and so on. Here there is a problem. The problem is that I have a little bit idea that this comes in the, like, this is t by 2, it should be t, and then t by 2 should become t square by 2, t cube by 3. Then it comes in the log 1 plus x expansion, but it's not the case here. So what we can do, let's try to understand this. The 357 comes in the expansion of log 1 plus x. So let's try log 1 plus x and see what will happen. Log 1 plus x expansion is x minus x square by 2, then x cube by 3, then minus x to the power 4 by 4, then x to the power 5 by 5, and so on. And because I need all the odd terms, I can subtract the expansion of log 1 minus x. So that will give you minus x, then minus x square by 2, minus x cube by 3, minus x to the power 4 by 4, minus x to the power 5 by 5, and so on. And when I subtract it from the top one, I will get here log of 1 plus x and minus of 1 minus x. So I can write directly at log of 1 minus x. And this side, what you get is 2x plus 2x cubed by 3 plus 2x to the power 5 by 5, and so on. But still the question is not solved, means our problem is not solved at that moment. We will see what will happen. See, this is going to be x, then x cubed by 3, x to the power 5 by 5, and so on. You notice I need not this thing t. I need the t by 3, rather t cubed by 3. And similarly t squared by 5, rather t to the power 5 by 5. So there is one remedy I have. What you can see, suppose what instead of t to the power n, because you notice that here this is the observation we have to do always, and now we are going to use this fact wisely in a very, very, very smarter way, and you will love to understand. This is the thing. Instead of doing this t to the power n, I observe this thing that when I'm just simplifying this log 1 plus x with 1 minus x, what I'm getting here is all the odd powers with odd denominator. So it means this is giving you the summation. If I ask in terms of t n goes to 0 to infinity, I can write t to the power 2n plus 1 divided by 2n plus 1. This will definitely give you half of log 1 plus t by 1 minus t, because this result you can use to write this in a shorter way, isn't it? But what I need is this guy. What I need is this guy. I need this summation, and there I need x by 4 to the power n, means almost t to the power n, no problem. So my aim is to get this x by 4 to the power n, and here I have 2n. So what I'm going to do, I'm saying here that summation n goes from 0 to infinity, and writing this thing as t into t square to the power n and divided by 2n plus 1. And this side, this t I have, I'm going to send it on the right hand side in the next step. This is, by the way, t here. So this t will go there, so I can write n goes from 0 to infinity, and this is t square to the power n divided by 2n plus 1, and this is half of t, means half t there, and log of 1 plus t by 1 minus t. In this way, what will happen, that this is the exactly similar case here, x by 4 to the power n by 2n plus 1. It means I can assume now t square is equal to x by 4, and so I have t is equal to root x by 2. So if we substitute there, that will give you n goes from 0 to infinity on the left hand side. This is x by 4 to the power n divided by 2n plus 1, and here what we get is 1 by root x, because 2 and 2 will get cancel, and here log of 1 plus, and this was t, so t is root x by 2, and again here 1 minus root x by 2. We can simplify it further, so that will give you 1 by root x, and here log 1 plus, or rather 2 plus root x by 2 minus root x. And this is our second, means S1 summation. Now S1 I got and S2 I got and already. So I'm going to substitute this thing in this complete S. So remember S2 was 4 by 4 minus x, and S I have. So this is going to be S. This is 0 to 1. S1 is 1 by root x log 2 plus root x by 2 minus root x, and into 4 by 4 minus x, perhaps, let me check, 4 by 4 minus x. That's okay, and that is going to be dx. So in this way we got this expression. Now our work is to find out the integral of this. Now notice one thing, that whenever I substitute this root x as t, its derivative is already present there, and so I'm taking this 0 to 1, and there I'm multiplying 2, and this is 2 root x log of 2 plus root x by 2 minus root x, and 4 by 4 minus x dx. What I'm going to do, that's not so difficult to understand. What I'm going to do is t I'm taking as root x. So dt is 1 by 2 root x. So you can see this 1 by 2 root x and this dx collectively can be written as what? Dt. And this 2 times 4, I can take it out as 8. So that is 8 here. And 0 to 1. Why 0 to 1? Because when I take the x 0, the t will be 1 only. And when I take x 1, the t will be 1. This is 0, by the way, sorry. 0 and 1. So root x doesn't get affected by the changing of limit. Means the limit will not get affected. So what I get here now is 2 is out, 1 by 2 root x is out. So I can write log of 2 plus t and by 2 minus t. And this is going to be 1 by 4 minus t square dt. Now if you have a lot of practice in definite integration, or maybe substitution in definite integration, you might have encountered this kind of situation, and you can notice that this quantity is the exact derivative of this quantity. Let me show you. If I want to differentiate d by dx of, or let us take this u so that that purpose will be also solved. So I'm taking u as log of 2 plus t by 2 minus t, which is nothing but 1 log of 2 plus t minus log of 2 minus t. And when I differentiate it, what I get? Du by dt is equal to 1 by 2 plus t, and minus minus plus 1 by 2 minus t. When we separate it, that will give you what? 2 and 2. That is added, that is 4 by what? 2, that is 4 minus t square. So I unnecessarily take this 4 out from here, so that is going to be 2 instead here. And then this is going to be, when we put t is equal to 0, that will become 0. But when we put t is equal to 1, that will become 3, that is log 3. Okay, now this is going to be t, this is dt directly, and so I have 2 times t square by 2, 0 to log 3. And of course 2 and 2 get cancelled, and we are only left with log 3 square. So that's the answer. So that's it for today's video. See you in the next video with some other interesting question that I think you must try. Till then, stay math active.